Okay, to start this section, you're going to learn about points in the Cartesian coordinate plane, which is this, the graph that you've seen before, where the horizontal line is called the x-axis, the vertical line is called the y-axis. Right in the middle is the origin, which is actually the point 0, 0. And so whenever you're asked to find a point, you're always given the x value first and then the y value. So if I said plot -3, -1, then you would go to the left, -3, and then down to this point. Also notice these quadrants. So quadrant 1 is where x is a positive value and y is a positive value. If you look at quadrant 2, x is a negative value, but y is still positive. And then quadrant 3, both x and y are negative. And then quadrant 4, x is positive, but y is negative. And typically in the real world, you're like, well, I've never seen anything that looked like this in the real world. You normally only see quadrant 1, right? Because you know, things that we look at, our bank accounts, we hope are only positive. And so this is very typical that we would only see quadrant 1. All right, and so then now that we know what these points are, also called ordered pairs, as in this case, it says complete each ordered pair so that it is a solution. So I can see in this first one, I'm missing an x, and the second one, I'm missing a y. So if I work the first one, missing the x, so I have x minus 3, notice it tells me y is -1 equals -6. Now this just becomes an algebra problem to solve for x. And if I subtract 3, I'll get -9. So that says the ordered pair is -9, -1. The same thing on this side. I plug in x is -3, and then -3y is what I'm looking for. And I solve this, so -3, I'm going to do a +3 on the other side, so -6 plus 3, -3. And then finally divide both sides by -3, and I get y equals 1. So that states this point, this ordered pair, is -3 and 1. Before I go into that, one thing that I want to mention also is, well, let me go back. This slide's probably the best way to mention it, is intercepts. So when you have an intercept, like an x-intercept, that means the point is on the x-axis and the y value is 0. So that would be an x-intercept. I could have an x-intercept here, which would be 5, 0. So notice the x-intercept is when the y is 0. The y-intercept now is when the x is 0. So this would be a y-intercept. So I wanted to get that thrown in there. All right, so when you have 2 points, you're given 2 points, you can find the slope between these 2 points, and as you're going to see, the slope stuff comes in as meaning the slope of a line. And we'll look at these on the graph, but if you have a positive number for your slope, the graph is going up. If you have a negative, the graph is going down. If you have a 0 slope, that means, I guess I should be doing this, right? That means that the slope is constant, it's not changing. And then you'll also see we can have undefined slopes. All right, so let's look at if I have these 2 points, 8 and -9, and 5, and if I can read my handwriting, -3. So I want to find the slope between these 2 lines. So what you do is the change in y over the change in x, as they typically call it. It really doesn't matter which one you call x1 and y1, but they need to both be 1. and then x2, y2. I tend to just follow the formula. So the formula says to take y2 minus y1. Be careful with those negative signs. So y2 minus y1, and then x2 minus x1, and so a negative and a negative, I get that positive, and then a negative, and so here I get 6 over negative 3, and so I get a slope of negative 2. So I know that this line is going down because this is a negative slope. I mentioned an undefined slope, how that happens. Let's say I have the point 7, 9, and 7, 7. Now if I do my y2 minus my y1, my x2 minus x1, do you hear sirens going off? Woo, woo, woo! You cannot divide by 0. So this would be what's called an undefined slope. All right, let's see what I got next. All right, so as I mentioned, we like to find the slope because that tells us the direction of our data. Okay, if something is increasing, decreasing, and if you put your equation in this format, this is called slope-intercept format. And what I mean by this format is you just solve for y. So if I give you y equals negative 4x plus 2, and I asked you what the slope is, and they call it m, it would be negative 4. And then this would be the y-intercept, which remember that means it would go through the point 0, 2. So the only time this gets kind of weird and crazy is if this is not solved for y, and I ask you what is the slope. Well, you just simply solve it for y. So you move the 5x to the other side, and now from here I can see that the slope is, negative 5. Even if you have, let's say you have something like y equals 2, and I ask you what the slope is, well, if I graphed this line, y equals 2, that would just be a, don't laugh at my ugly line, that would just simply be a horizontal line, and remember, that gives you a slope of 2. I was looking to see what else is here. So the only thing you have to be careful of is when the equation is not solved for y, then you just need to solve it for y to be able to find the slope very quickly. All right, so they gave you a couple of questions, and I didn't want these to be confusing. Like they tell you to find this slope. Well, if you remember the slope, I know it was given the y2 minus y1 over x2 minus x1. How you typically see this written is the rise over the run. Because think about it, the y is the vertical and the x is the horizontal. So in this case, it's actually easier than what this actually looks. This would just simply be the rise over the run. And then I think I can divide by 2. I'm just trying to see how I can simplify this and get 5/8 for the slope. This one here, the grade of a road is its slope with a percentage. Find the grade of the road shown. Once again, we have a rise over a run. And if you throw this into a calculator that I cannot seem to find right now, 2 divided by 23, I get 0.08696, blah, 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 blah. And they want it in percent. So remember, move that decimal 2 places, and then round this one, I'm going to round to 1 decimal place. So that's a 9. The 6 is going to go up, and we get the percent. So you're going to see this is finding the slope is something definitely that is used. I've even seen things where they talk about the actual slope of wheelchair ramps. You can see the pitch of a roof. Definitely something used in the real world. So get this stuff down so you'll be ready to move on to the next section.